G'day, g'day, g'day. Welcome to further symmetry properties of the Pythagorean identity. Yes, I'm becoming more Australian as time progresses. I think I've got the accent down pat. My apologies if I'm offending anyone. Not intentional, but yes, I'm finding myself becoming more Australian. So, welcome, those of you in internet land and for those who are being taught by me. This video is going to be dealing with further symmetry properties and the Pythagorean identity. Those of you who are cursed with having to be taught by me will need to complete the work here. Only one question on the Pythagorean identity. Wow, where's the further symmetry properties coming? To be honest with you, it is no different from all of the other work that we've done. I will come back and do a video on that at some point later in the future. It's not needed at this moment in time. But if we do a quick recap, we've looked at the fact that we can use the unit circle to help us find values of sine, cosine, and tan for angles between 0 and 360, or if we're dealing with radians, 0 and 2 pi. We use this ASTC, all stations to Canberra, to help us realize that given a reference angle, we can use this to find angles in other quadrants. So for example, here is my sine of 150 degrees. There is my unit circle. Boom, boom. 0, pi on 2, pi, 3 pi on 2, and 2 pi. Now, is that helpful to me? Because no, they actually wanted it in degrees, but I could always write 0, 90, 180, and 270, and 360. Already this is looking confusing, but keep with me. So sine of 150 degrees. I know 150 degrees is going to fit here, so that would be 150 degrees. We always work anti-clockwise. And I want a reference angle. I am looking for the angle between that and the x-axis, so that's 30 degrees. What I now know is that the sine of 150 degrees is the same as the sine of 30 degrees. That's why this reference angle is really important. That was all the theory that's done before. All I need to work out is whether it's going to be a positive or a negative. Is the sine of 150 equal to the positive or the negative of the sine of 30 degrees? How do we know that? All stations to Canberra. S, in that quadrant, all sine values are positive, so that would suggest that the sine of 150 and the sine of 30 are absolutely equal to each other by putting a plus in front of that there. And I know, because the sine of 30 is 1 that I learned in my head, that's equal to a half. Now, there are other ways of doing this, but there are other ways of finding angles. Now, remember Pythag? He was an alleged murderer, all right? He started a sect and he basically decided that all numbers could be expressed as fractions. Unfortunately, there was one of his students who decided that probably that wasn't true, and in fact, he went away and proved it wasn't true and chose to tell Pythagoras and many of his loyal followers this piece of information on a boat, on a river, or in the sea. Now, I don't know about you, but if I was going to turn around and tell my teacher something that would suggest he was wrong or she was wrong, probably wouldn't choose to do it on a boat. Yes, you can see where this is going, because allegedly Pythagoras decided he didn't want his theories to be criticized and threw the guy overboard. Now, bearing in mind all of his followers were loyal, I'm not too sure how this story has propagated through the ages. Who would know? But gossip is an interesting thing, all right? So the chances are, because he basically, theoretically, we are led to believe, passed off a lot of students' work as his own, he probably didn't come up with a squared equals b squared plus c squared, or in Australia, c squared equals a squared plus b squared. He certainly created his own religion. He hated people who questioned him, and as I said there, he allegedly murdered someone. He may have allegedly murdered many people, but I don't know, he's not around today to actually prove that. So the theory he badged today can be used in unit circles. Here is my right angle triangle there. We know that it's 1, and we know that this is theta here. Now, if we remember, horizontal distance was cosine theta, and vertical distance was sine theta. Now, not only can we use right angle triangles with trigonometry, we can use it with Pythagoras theorem. So we know then that c squared is equal to a squared plus b squared. Well, c is 1, and that's squared. Sine theta squared plus cos theta squared. And that is more traditionally written as the sine squared theta. And yes, it's important to know that sine theta all squared and sine squared theta are the same thing, plus cos squared theta equals 1. That is so important. Now, using the unit circle and Pythagoras theorem, we can actually go on and prove and find angles in a very, very different way. All right, so what does it have to do with anything we're doing? But if you don't know, that's an actual book, The Price of Fish, a new approach to wicked economics and better decisions. I swear someone stole that from me, but anyway, whole new discussion. All right, so we can use his theorem and the knowledge we have to answer some pretty excellent questions. Right, so for example, if the question here says, you are given that the cos of x is 3 on 5, and you're told that x has to fall between 3 pi on 2 and 2 pi, we have to find sine x and tan x. Well, if I had an exam question that said this, I'd automatically be screaming all stations to Canberra. Why? Because 3 pi on 2 and 2 pi. So let's just draw a quick sketch. Here we go. Here's my unit circle. There's 0, pi on 2, pi, 3 pi on 2, and 2 pi. So first things first, we are looking for it to be in quadrant 4. So we're looking for a solution of cos x equals 3/5 in there. Right, so cos x equals 3/5. Well, we know that the solution has to lie there, but what's it got to do with Pythagoras theorem? Well, we've just found that sine squared of the angle plus cosine squared of the angle is equal to 1. And because they want me to help find sine and then tan, and we'll come back to tan later, I can use this identity. Right, so sine squared theta is equal to 1. Now I know what plus. I know what cos x is. It's 3 on 5 squared is equal to 1. So some algebra now. Sine squared theta plus, well, when you square both things inside. And I'm now going to take away 9 on 25 from both sides. So sine squared theta is equal to 1 minus 9 on 25, which when I went to school was 16 on 25. Right. So sine squared theta. How do I get rid of the squared? I square root both sides. So sine theta is now going to become the plus or minus of 16 on 25. Now it's really important that you have the plus and minus. Why? Well, because there are two solutions. I'm going to make that slightly easier, and I'm going to square root both the top and bottom. So that's going to become plus or minus 4 on 5. Now, the thing is, it wants to know the solution that falls in this quadrant here. All stations to Canberra. In that quadrant there, only cos can be positive. So I now cannot have that sine theta is equal to positive 4 on 5, because cos is the only thing that's positive. Sine has to be negative, so therefore I now know that sine theta becomes equal to minus 4 on 5. Easy peasy lemon squeezy. How do you then find tan? Well, if you remember, tan of x, or theta as I've obviously now decided to rename it, is equal to the sine of theta divided by the cosine of theta. We've just worked out the sine of theta is minus 4 on 5. I'm going to do divided here deliberately because we're dealing with fractions. Divided by the cosine of theta, which is 3 on 5. Keep, change, and flip. They cancel, which gives me minus 4 on 3. Now I'm really happy that it's minus because, again, in this quadrant here, tan has to be negative. And so using Pythagoras' theorem, we can actually find some angles. A lot of other people will be like, really? Do I need to do it that way? Can I not do it another way? Again, totally up to you. Depends what the question's asking you for, to be honest with you. If you knew that, what was it, the cos of theta was, what did it say, 3 on 5? Personally, I'd have just done inverse cos of 3 on 5 and then just worked out the value. But that's just me. All right, this was a really, really swift lesson, just showing you how Pythagoras' theorem and the unit circle created this Pythagorean identity, which we could use in questions like this to help us find other values. Okay, thanks very much for watching. I look forward to seeing you next time. Thanks so much for joining us for that video. It was really good having you. Now, if you'd like to know when the next video is coming, why not click on subscribe? Alternatively, head on over to mathsguru.com where you can watch all of the videos on its own dedicated website. While otherwise, watch the video that's just popped up. It'll be part of this series. All right, take care. See you again soon.